Hello everyone, and this is the last problem of this topic, which is the instantaneous center. So we have a piston cylinder that has a crankshaft of AB and with a connecting rod of BC. Then the angular velocity is 10 radians per second. Determine the velocity of the piston at the instant shown. This is the question. Okay, so let's solve it. Firstly, I will start with so I will show firstly the diagram here. So we have the point C, then point B, and then point A. And then actually these should be connected here. A little bit longer maybe. And the angle here is 45 degrees. And this angle is 13.6 degrees. And then B rotates this way. So actually this one should be a little bit longer. Then point C, and then B goes that way. That's the velocity of B, which is 90 degrees to that one. This is point A. The reason is you can see that A is pinned. Then the B, if I draw it here, that is A. And then B is connected this way. So B can rotate that way and then this way. You can see it makes a circular action. For this circular action, the tangential velocity of B should be perpendicular to the radius. Okay, this makes a circular action. Okay, and then this one is 13.6 degrees. And then C, the piston moves up and down. And then I will, as you can see from here, if it moves to the right, then the piston will move to the up. So I will say that the piston VC is that way. This velocity C. That is upwards. Okay, and then the question is that how can I find the instantaneous center for B and then C? So there must be a center that B and then C are rotating with respect to that center. For B, it is very obvious that, and as well as for C, that instantaneous center, let me say this one, yes. If you remember this image here, the instantaneous center is perpendicular to these velocity vectors. So it means that if I find an instantaneous center for C and for B, it should be perpendicular. Let's find first for C. C makes a, we can assume that it makes a circle something like this one, and then it will have a 90 degrees here. Okay. I don't know where it will end, but at some point it will have an instantaneous center. And the B also makes a circular action, and it needs to have the instantaneous center as well. So again, it will be perpendicular. Okay, this should be perpendicular to this velocity vector. As I said in the previous recordings, so you can never stop here and then say that this is the instantaneous center for B, because in that case you will have two unknowns. But what we are looking for one instantaneous center, so it will be that we are looking for this point IC. You can also check, this one is very similar to this problem here. This problem. You see, I have point A, I have point B. There is a common center for A and the B such that A and the B rotates around that common center. Similarly here, I have point C, I have point B, and there is a common center for A and then B and the C. Okay, there is a common center, we call it the instantaneous center, such that B and the C rotates around that center. Okay. Since this one is 90 degrees and that angle is also 90 degrees. Okay, 90 and 13.6, and therefore that will be 90 minus 13.6, that will be 76.4 degrees. And then we have this angle as, so let's see, we have 45 degrees, we have 13.6 degrees, and then this angle will be, that angle is 121.4 degrees. You can check, the sum is 180. Okay, and then 76.4, 121.4, and this one makes 180. So that angle will be 180 degrees minus 121.4 degrees. And that will be 58.6 degrees. And then we have here, the summation should be 180, and that will be 45 degrees. Okay, and this part is RCIC. This part is RBIC. Okay, so let's see what we have. We have 0.75, which is B to C. Okay, and then the rest is unknown. But we can use the law of sines. 0.75, or we can say BC by sine 45 degrees will be equal to C RCIC by sine 58.6 degrees. That is also the same as RBIC by sine 76.4 degrees. If you do this calculation, this one is given, the first one. That is 0.75 feet. Okay, this sine 45 and then sine 58.6, sine 76.4. You can find these angles very easily. So, but if you do this calculation, you will reach that RCIC, that is equal to 0.0905 feet. Okay, so this one is 0.707, and that one is, if I can find, that one is 0.853, and sine 0.972. Okay, this is RCIC. Similarly, RBIC, that will be equal to 1.03 feet. Okay, so since we have found this RCIC and then we know this length and then we know this length, we can find the velocities. So let's do that. The velocity of B will be equal to, this is the velocity of B, RBIC. So let's come back here. The velocity of B is that velocity of A plus the distance times the omega. So that will be velocity of A plus omega into RB with respect to A. This omega is given in the question as 10 radians per second. Okay, and then the RBA is given as 0.25. Okay, then velocity of A is 0 because it doesn't move. Then it will be that 2.5 feet per second. That's the velocity of the B. Velocity of B, so this one is velocity of B with respect to A. I can find the velocity of B with respect to IC as well. That will be velocity of B, velocity of IC plus then omega into R BIC. And this one is 0, it doesn't move. And this one is 2.5. RBIC I just found, it is 1.03. From here I can find that omega will be equal to 2.43 radians per second. So the velocity of C again will be omega into RCIC. Okay, then omega we just found, which is 2.43, and then RCIC is 0.905. Okay, from here it makes 2.20 feet per second. Okay, that is the velocity of the piston, which is 2.20 feet per second that moves to up.